Hello everyone and welcome to the course Design Borefields with Confidence. This is the introduction of the third part of this course, but before we jump into what we will learn in this part, I want to summarize what we've been doing in part 2. Now, part 2 was all about getting you started with your first geothermal simulation. So we talked about monthly temperature profiles and hourly temperature profiles, and more specifically what we can see on them and what we can learn from them without actually simulating anything. And we did it based on the concepts of the borefield quadrants. Now after that we started with talking about borefield physics, and we introduced two very important elements in the world of borefield design, which was on the one hand the effective borehole thermal resistance, which told us something about the fluid temperature and its relationship to the borehole wall temperature. And we know this was influenced by the flow rate and the convective heat transfer, the type of heat exchanger you use, a single or a W tube, or perhaps even something else, your type of grout, and so forth. And this all had to do with the short-term response of your borefield. It's a power problem. But on the other hand, we also have a long-term temperature drift of your borefields, which is governed by the energy you're extracting and injecting from your borefield, your imbalance. This was described by the G functions, the ground response functions. And the G functions tell us something about the long-term effect in the order of seasons and years. And this was then influenced by the borehole-to-borehole spacing and your configuration and so forth. Now in part 2.4 we actually used all these insights on a case study, and we simulated our first borefield using traditional historical assumptions. And that we did to learn about the borehole resistance and the G functions and how everything played together. And over the different scenarios in this part 2.4, we actually were able to reduce our borefield size significantly, just to show how powerful and how many design variables there are so that you as a designer can make a better borefield design. And that goal of making better designs is actually the main goal of part 3 of this course. So as said in part 2, we used traditional assumptions. Now with GHE tool, we actually wanted to go further than that. So we are pushing the market towards more newer state-of-the-art mathematical models. And that's the goal of this part. So we will start again talking about monthly and hourly temperature profiles, but now not so much about what we can see on them, because we already know that, but we will talk about what the advantages are of using hourly simulation versus monthly ones. And it's not about accuracy, because it's a little bit vague and a difficult term, but it's more detailed using hourly profiles, and you can avoid oversizing significantly when you use them. So that will be the topic of part 3.1. In the second chapter, we will start by explaining the first of 3 major improvements we made in GHE tool that can actually help you design better borefields. And the first one is using variable fluid properties. Now, perhaps you recall that in chapter 2.4, you actually had to set this off when doing your first GHE tool simulation and use constant properties. Now, when you're using variable fluid properties, you will see that your viscosity, your Reynolds number, and your borehole resistance will actually become temperature dependent. And this will have a major impact on your design, especially when you're working with quite a lot of cooling on your borefields. Now, the third chapter will go about variable flow rates. Because historically, we all say, well, let's work with a constant flow rate during peak powers, peak moments and off-peak moments, and the same during heating and cooling. But of course, this is not what happens in reality, and also this can lead to misinterpretation of how your geothermal system behaves. So variable flow rates will be the topic of chapter 3. And in chapter 4, what we will talk about is variable efficiency. Because if you recall part 1, chapter 5, if I'm not mistaken, we talked about the heat pump efficiency being used to translate our building demand to a ground load. And this ground load is then used for the powers and the short and long-term effect and so forth. And we said, well, this efficiency is an input, but it depends on how you define efficiency. Because if you use an SCOP, the seasonal coefficient of performance, well, that's actually not an input. That's an output of the simulation. And this is a common misconception or a wrong assumption we've been using for decades. And with GH2, you can actually get this efficiency as an output instead of an input. So we have quite a lot to cover. Please make sure that you understand everything from part 2 of this course, because we will build further on that. And it's important that you are really understanding everything so that you are able to add all this new information to your web of beliefs, so to speak. So I'm looking forward to seeing you in our next video, where we'll be taking about hourly and monthly temperature profiles.